Hey guys, Jason Jeffries here, Master Jace for the Alliance Project. I have some breaking scientific news to release with you guys. Thought it was very interesting. For the first time in human history, we ever watched two neutron stars collide. I'm going to go ahead and share what I have with you. It's a really big deal. If you watch documentaries and things on it, they believe that it would cause what they call strangelings, which turns things into strange matter and cause a chain reaction that would, in theory, swallow the whole universe and convert it into this matter. We actually, Einstein theorized this with what he called gravity waves, which is actually a ripple in the space-time continuum. So I'm going to go ahead and share this with you. Astronomers strike gravitational gold in colliding neutron stars. For the first time, scientists have caught two neutron stars in the act of colliding, revealing these strange smash-ups are a source of heavy elements such as gold and platinum. The discovery announced Monday at a news conference in a scientific report written by some 3,500 researchers solves a long-standing mystery about the origins of these heavy elements, which are found in everything from wedding rings to cell phones to nuclear weapons. It's also a dramatic demonstration of how astrophysics is being transformed by humanity's newfound ability to detect gravitational waves, ripples in the fabric of space and time that created when massive objects spin around each other and finally collide. It's so beautiful. It's so beautiful it makes me want to cry. It's a fulfillment of dozens, hundreds, thousands of people's efforts, but it's also a fulfillment of an idea suddenly becoming real. It says, Peter Salson of Syracuse University has spent more than 3 decades working on the detection of gravitational waves. Albert Einstein predicted the existence of these ripples nearly a century ago, but scientists didn't manage to detect them until 2015. Until now, they've only made 4 such detections. Each of these time distortions in space-time were caused by the collision of 2 black holes. The bizarre phenomenon, however, can't normally be seen by telescopes that look for light. Neutron stars, by contrast, spew out visible cosmic fireworks that are when they come together. These incredibly dense stars are small as cities like New York City and have the mass more than our sun. In this case, what scientists managed to spot was a pair of neutron stars that likely spent more than 11 billion years circling each other more and more closely until they finally slammed into each other about 130 million years ago. You got to remember, it takes light that long to get to us. Here's a rendering of what happened. These explosive impact created ripples in space-time that traveled all the way to Earth, arriving at 8:41 Eastern Time on August 17th, setting off detectors in the Laser Interferometer Gravitational Wave Observatory, whose founders won the Nobel Prize in Physics earlier this month. That morning, all of a sudden, scientists' cell phones began to ring. Alarm went off in my pocket. David Shoemaker of MIT, a physicist who serves as a spokesperson for the LIGO scientific collaboration. He had been in a mundane organizational meeting, which immediately was abandoned. The morning was transformed from ordinary bureaucracy to a morning of slightly breathless discovery as we tried to discover how we could most quickly get to the news observers as we tried to make the most of the event. What LIGO had seen did not look like the calling card of colliding black holes. Importantly, 2 seconds after the gravitational waves detection, an orbiting NASA telescope registered an extremely powerful explosion called a gamma ray burst. It apparently came from the same region of the sky that had produced the gravitational waves. That put us in a very high state of excitement. Quickly, the LIGO team consulted with colleagues at Virgo, another gravitational wave detector lab near Pisa, Italy. The lab had detected the waves too, and their data had pinpointed the exact patch of sky where the astronomers should aim their telescopes. Location was in the southern skies, which meant the first place where the astronomers could get to work was Chile, and he was asleep. I actually woke up in the afternoon because I work all night when I'm observing, and I just looked at my phone and I saw it covered with emails. Says Shappy, professor of the University of Hawaii, who was a Hubble fellow at the Carnegie observatories during discovery. My first thought was just, we're in the perfect position to try to find this. He and his colleagues began a mad scramble to figure out which galaxies to look at with which telescopes. As soon as the sun went down in Chile, they started searching for a new source of light among the familiar stars. Almost right off the bat, maybe 15 minutes into observing, I get an email basically saying they found something from the SWIP telescope, which is amazing. And I get an email almost immediately from Josh Simon saying he was on the same galaxy. He took another image and found the same source, and it's real. And so at that point, I said, this is almost too easy. Less than 11 hours after the gravitational wave detector sounded the alarm, astronomers had their first glimpse of this never-before-seen event involving neutron stars. The Carnegie team worked quickly to make observations because it only had about an hour until the spot was no longer visible in the sky. It was probably the most surreal experience of my professional career. It was completely unexpected, out of the blue. We started scanning the region of the sky where the Liga told us the gravitational waves come from, and it took us 45 minutes until we found it, said Edo Berger, as an astronomer of Harvard Smithsonian Center for Astrophysics. It was an incredibly amazing moment because it just stood out. It was kind of like searching for treasure and seeing the X marks the spot. What all the images showed us was a brand new point of light that started out bluish and then faded to red. The red and blue Kachina, right? But this didn't completely match the theorists when colliding neutron stars should look like. It was all the code. It was all close, but it was all close enough that Daniel Kaysen, a theoretical astrophysicist at University of California, Berkeley, found the experiments a little weird. Even though it was an event that had never been seen before in human history, what it looked like was deeply familiar because it resembled very closely the predictions we've been making. Before the observations, what happened when two neutron stars merged was basically just a figment of theorists' imagination and computer simulations. He spent the night watching the data come in, says the colliding stars spewed out a big cloud of debris. That debris is strange stuff. It's gold and platinum, but it's mixed with what you'd call just regular radioactive waste. And there's a big radioactive waste cloud that just starts mushering out from the merger site. It starts out small, about the size of a city, moving so fast, a few tenths of the speed of light. Then after that, it's a cloud the size of a solar system, according to his estimates. The neutron star collision produced around 200 Earth masses of pure gold, 500 Earth masses of platinum. It's ridiculous. Huge amount on human scales. He personally has a platinum wedding ring, and said it's crazy just to think these things were very far out of the exotic to actually impact the world us in intimate ways. The discovery has consumed the astronomical community by recent weeks. By my count, 70 astronomical telescopes started looking for this event in the area of the key sky. This event, in some sense, is the first event that we've seen in gravitational waves and light. It's a new way to look at the universe. What could gravitational waves help astronomers see? If we're lucky, we would see a supernova from somewhere in our galaxy. He notes that these star explosions go off every 50 years or so. Perhaps the next cataclysm on deck will be something like a black hole colliding with a neutron star. So what I'm going to do is show you something. Let me see here. One second. Maya. Maya! So what I want to show you is, let me see if I can find it. Let's see if this is it. It might be it. But they call them strangelings because they don't know if they exist or not. And they can completely wipe out an entire solar system. All right. Chronic flatulence. All right. So what I wanted to show you was the strangelings. It's like a theory they have, but it's really neat. See if it has. Let's see if I can do it. Find it. Oh, pause this for a moment until I find it. Hope you guys enjoyed that. Didn't say what I wanted to about the about the strangelings, but basically it turns things into strange matter, and that's chain reaction, touching everything it touches, just ever expanding into strange matter, and it's just it's wild stuff. But they believe it only happens when two neutron stars collide. So we found out it happened yesterday, and well, we perceived it yesterday, which happened 130 million years ago, but we're only watching it now because of the speed of light that travels, and yeah, that's weird to think about, right? But yeah, hope that was fun facts for the day, and hope you guys all enjoy.